All right, let's go. All right. Welcome everybody. Welcome to the chat. Let me see. Continue. Go. Hello, root at localhost. Welcome. I need to just change this couple of seconds. Just a minute. Two, 388. Yes. Yes. Everything is set. And today is gonna be really difficult because I had to become a genie to solve these levels of Behemoth because it is Behemoth. If you don't know what a Behemoth is, it's really very ferocious beast. So this is like the description of it, but it could be anything. Could be most I don't know, very difficult to understand, but difficult to deal with. Okay, so Behemoth level 2. So first of all, global rank is 2388, country rank is 37, and today we're gonna go and beat this bad boy 17, and that's our target. We're gonna cross this guy and reach to the next level, and we'll see how it is done. Okay, Abhinav, this is not bug bounty. This is like global rank, global hacker rank. Like they can, if you go to this vchel.net, if you are a user in this, like you will have a world rank in this, and you can link all the websites which are there. Like you can link Hack the Box, you can link Over the Wire, and you can link so many of these websites. And whenever you solve something in those websites, which means you leveled up in that website, so that will be reflected in this account. Okay, say for example, I clicked on, okay, let me go to this account. And as you can see, I have linked 3 websites. So VCHEL is this website, and Hack the Box is the Hack the Box website, and Over the Wire, like Over the Wire, we've been doing Over the Wire a lot, right? So you can link those websites to this website, and whenever you solve something, your rank will be increased, and you can use that as the leverage to get ahead in your career as cybersecurity professional. Okay, so that's the idea. So today we're gonna do a couple of over the wire challenge and beat this bad boy 17, right? So let's get started. So I have already moved to this directory, so it's better to be organized. So clear SSH Behemoth 2. If you saw the last last live, we have already solved Behemoth 1 and Behemoth 0. Today we'll be solving Behemoth 2 and Behemoth 3. It's gonna take a hell lot of time, and it's gonna be interesting. It is binary exploitation, so we don't even have any kind of code. So if you see this, all of these are binaries. So all these binaries, we need to exploit it and get we need to have certain knowledge to even exploit these things, right? So if you do that, like, you will gain the knowledge of binary exploitation, and you can use that in your private bug bounty programs, not in public ones. Public ones are mainly web 3 and web 2, but not binary exploitation. But if you see Chrome bug bounty programs, they will pay thousands for this kind of thing. Chrome bug bounty, just like any other binary, you will have like huge rewards for solving these things. So rewards, let's go to this page. I'm not sure if they will reveal the rewards, because whenever I saw it is like 8,000 and 9,000, $10,000 for each vulnerability. So there's huge opportunity if you learn how to use this binary exploitation techniques. Okay, right. So since I am Behemoth 2, I have only access to run this file. Okay, since it is set UID permissions, like, I will be running this as Behemoth 3, but we have to use this to gain access to Behemoth 3 and try to pop up a shell. Okay, so let me see. Okay. Right, 1 second, let me see the live chat. All right, let's see, Behemoth 2. Okay, so basically when I run this file, what's basically happening is it's trying to run the touch command, and it says touch cannot touch this one, permission denied. Right, so let's try to understand what's going inside. And see, this one is just hanging right there, it's not even giving us the shell back. So I just press Ctrl C to exit out of there and try to understand what this is. Okay, so first of all, let's say ltrace, and let's try to run the same file. So ltrace is basically it will trace all the dynamic linked libraries, and it will try to just print out what's going on behind the scenes. Okay, so let's see. And as you can see, first of all, it gets this process ID. Okay, so gets the process ID. Once it gets the process ID, this is the process ID, and it uses this print. Okay, so basically it's just printing this, touch this. And snprintf is not like normal printf, so snprintf is slightly different. So basically snprintf does not print it to the console, it just prints it to a buffer. Okay, so it just stores this into a buffer, and what is it doing? It's just copying the process ID. Okay, so the PID, and trying to touch this file. So what basically this touch command does is, so touch command has two functions. So basically, if I just try to, let's say, mkdir behemoth 2 cd behemoth 2, and let's say I touch ASDF. So I don't see any output, but a file has been created. Okay, and if I type ls-l, I can see this time here, right? But if I touch this again, touch this file again and try this, as you can see, the difference between this one and this one is basically the time has changed. Okay, so basically it just touches this and makes no changes if the file exists. Okay, so this is basically used for backing up files and everything. Like let's say I have touched this file, I know that this file has been the latest one, and it just creates like an update that I have access this file recently. So once you understand this, so basically it just creates a file and updates the time of the file. Okay, so two functions. So let's exit out of here. Let's see. Right, so let's go back. And as you can see, sleep 2000, so it's just taking up the shell, I mean the prompt, by just sleeping for 2000 seconds, right? It's not a big deal. And once it does this one touch, and then it gets the, and it unlinks this one. Okay, so unlink is basically deleting a file. So all these are C functions. So if you want to know about these functions, all you have to do is just type man unlink. Okay, and you can also type man anything else. Okay, sn sprintf. Okay, all of these are C functions. So basically you can access all of these manuals, okay, directly here. You don't have to even go to uh, internet. Okay, so all of those are already in the Linux machine. So unlink file basically deletes the file, right? So here it's just getting the process ID and trying to store this string in a buffer and not doing anything, and then deleting the file, getting the effective user ID, and this is the one Behemoth 2. If it was like not without ltrace, it should be like effective ID should be 13,003, because we're running as Behemoth 3, right? Because we have set UID permissions. So and once it gets the effective user ID, it just sets the effective user ID, and it just runs the system command, which is touch and then this file. Okay, so if it has permissions, it will not show this. If it does not have permissions to the local directory, then it shows this permission denied option. So once the sleep is done, then we will get our shell back. Okay, so let's do one thing. Let's create a temp directory, and let's name it as mkdir/d. we creating a directory and storing the name of that file or the directory into this temp variable. Okay, so basically, okay, mkdir, okay, sorry, so it is mktemp. So we're creating a temporary directory. So temp has a weird name like mktemp/d. It will create a temporary directory immediately with a weird name. So you can just directly go to that temp just like this, which is like you cannot remember or type this, right? So it's better to store it in a variable. Okay, and you also need to give all the permissions in the world to this temp directory, just to show like whenever you have some files here, the other files, let's say the touch command is being executed here, right? So if it creates a touch command, then you need to have access, I mean that binary should have access to this local directory. Okay, so basically if you type Behemoth and Behemoth 2, now as you can see, you don't see any such error messages, right? But the sleep command executes. So just cut it, and if you type ls, you will see that file. Okay, is there anything in that file? Cat 8, and there's nothing. It just touches the file, it doesn't create anything. Okay, it does not store any kind of data. Okay, right. So hang on a second, looks like Is this bothering? Yes, I need to change some things. Um, ta- 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 ta. Let's move. Okay, let's move it to the bottom, to the right. Sorry. Probably right here would be better. Right. So that you can just see this text in between. Okay. So, where were we? Okay. We were just talking about this cat command, and yes. So, the file has been created, but it's not doing anything. So, how do we get this? So, since we know that touch command is being executed, what we can do is we can it does not create any like what do you say, like it does not create full path. Okay, basically it does not use, is not using absolute path, it's only using relative path. So when it is using relative path, we can do something like we can create our own touch command. Okay, so basically so I'll just say nano touch and I can just type slash bin slash sh. Okay, something like this. Basically I want to run a shell using my own touch command. Okay, so if I type ls, I can see touch, it is a text file. Okay, so I need to convert this into binary. So chmod 777 and touch. Okay, so now if you type ls-l, you can see that it's a executable, right? So to give this directory in, so that this function, which is system function, will actually execute this command. So what you need to basically do is you need to give this location, which is actually, which you just type touch. So this is the location where the touch command is running. Okay, and you just have to know this path variable. So path, in this path variable you can see user bin in this particular location right here. Okay, so basically all these are locations where you can fetch binaries from. Okay, so I can add to this variable my own local directory, which is this one. Okay, so you can add this in a couple of ways. So first of all, let's say I can just type a path and equals to, I can give $temp colon $path. Okay, so I can give something like this. So what's gonna happen if I type echo $path? You can see that this local directory, which is stored in this temp variable, will be prepended. Okay, so if you keep this location at the end, that will be a problem, but if you keep this in the beginning, the touch command will, where we're executing this touch command, will be checked right here. Okay, first here, and then it will go for user bin right here. Okay, so now if I type touch command just like this, you can see that I'm popping up a shell. Okay, so I'm popping up a shell as Behemoth 2. Okay, I don't have Behemoth 3 user. Okay, so if I type who am I, Behemoth 2, right? So I exit out of here, and now I can actually run Behemoth 2. Okay, so if I run this, the system will check for touch command, which is located in this path variable right here, and it will execute this shell. Okay, so if I type who am I, now I'm Behemoth 3. Got it? I hope you got it. Now let's move on to the next one. So basically once you get Behemoth 3, you can actually get cat slash etc slash behemoth. Okay, Behemoth underscore pass Behemoth 3. Okay, so you can get the password like this. Okay, but let's learn something different. So let's paste this echo dollar path anyway. This time I'm gonna set this back to original path. Okay, so basically path equals to this one. So if I type echo dollar path, I should see only this much. I'm not seeing a temp directory right now. So if you cannot type this, or if you did not use a temp variable, so there's some shortcut you can use. This is only for temporary usage. So just type path equals to dot colon dollar path. So what this dot will actually do is it will just look for local directory, which is current directory right here. Okay, so if you type echo dollar path, you can see that a dot has been added, right? So you need to understand that this dot is temporary, which means like if you change this directory, it will not look for touch command in that particular directory. Okay, so currently I am in this directory, touch command is in this directory, so I can use that, right? So if I type slash behemoth z and behemoth 2, now I pop up a shell, right? But if I change this directory and use the same command, you can see that permission denied because it's looking for local directory, right? So let's go back. Let's say cd $temp, very handy. And yes, so let's say your task is to pop up a shell and you popped up a shell, right? But what if your task was just to print out the password for that file? Okay, so all you can do is you can directly write this command right here. So behemoth underscore pass behemoth 2, I mean 3, right? So I'm directly printing out the behemoth password to the console, and I can actually run this. Okay, so multiple ways of doing it once you know what to manipulate and how to get that right. So I hope you don't have any questions right here. Let me see the chat. Okay, there's one more thing you can actually do. Okay, so let's see cat etc shells. So basically I use the first shell, right? I can use any one of these shells. Okay, so let me try to use this shell. This shell is interesting because it seems like you won't be seeing any changes, but you will be seeing changes. Okay, so watch carefully. I'm just running a bash shell right now. So behemoth 2, right? Watch this, it's running from behemoth 2 and suddenly it's behemoth 3. Okay, seems like nothing have changed, but you need to check this username. Okay, so and if you get out of this, I mean exit out of this, now the sleep command is running. Okay, so very interesting once you know what to do, right? So is there any other way you can do this? I think I have covered almost all of it. Right, so let's save this password. Control Shift C, open this. I'm just storing it right here. Okay, so exit SSH and behemoth 3, and this is the password, and now you're into Behemoth 3, right? So cd/behemoth and ls-l will give this files, and now our focus is on this file Behemoth 3, right? So Behemoth 3 can execute, and when he executes as Behemoth 4 because of the setuid permissions, right? So Behemoth 3, identify yourself. I'll just type ASTF and welcome ASTF and goodbye. Interesting. So this is very interesting. So let's type ltrace on the same file. So Behemoth 3. Okay. So now there's a printf which is just printing out this thing, right? And if I type ASTF and hit enter, few more functions, printf and puts. Okay, so basically if you see like Behemoth 0 or Behemoth 1, gets command has been used previously. Okay, so now puts command is being used. So the remedy for gets command, like gets command does not limit any buffer. Okay, you can basically give any number of characters into gets command, but if it is fgets, that's a different story. So it also says that the maximum you can give is 200 characters, right? So it just says 200, but it actually gives one less than that, because the last character has to be either this null character, the new line character, or null character like \0. So basically it just only keeps 199 characters. So we can actually prove this. Okay, so first of all, let me see the chat. This chat is not active today, everyone's sleeping. And let's see. So ltrace, so we already used ltrace, so let me just write that again. Behemoth 3 and identify yourself. Let's keep a bunch of A's. I hope I'm audible, right? Yes, I'm pretty audible. So let's just print bunch of A's, and if I hit enter, you can see that this is much bigger than this, right? Why? Because it's only storing 199 characters. So you can actually prove this just by opening word count, letter count, character count, and if you just paste this, count characters 199. Okay, so hope you can see this one, 199. So now we have a limit, and once, like if you use fgets, you're still not perfectly secure. Okay, so fgets is the remedy for gets command, but still if you're using fgets, it's not the only remedy you can use. You have to take care of other functions as well. In this case, puts function. Okay, so this is currently vulnerable. So puts function is in C language is vulnerable to format string attacks. So if you change some format into some other format, we'll just show in a few minutes, so it will still allow that format to execute. Okay, so we can use that format string vulnerability to actually point this puts function to a different function or a variable. Okay, so basically we want to run a shell, right? So we'll use a shell code. We'll just point this function to a shell code, and that would actually work. Okay, so let's see how it is done. So first of all, you need to have like GDB. So there's an advanced version, like there's an what do you say, community version of GDB, that's pound GDB. I mean pound debugger, so DBG. So this is not active right off the bat, so you need to make it active by keeping some commands. These commands are actually in the Discord server of this over the wire. Okay, so if you go to this information section, you will see some contact page, I guess, contact via chat and Discord, right? So go to this Discord and you will see some channels, and one of those channels will have some kind of notifications, and in that it will be having these commands. Okay, so basically you just paste it like this, and you won't be seeing this last command, so I had to come up with this command, and this would solve all the issues. So basically they will give only these commands which are on the top. The last command you need to actually execute. Okay, so if you hit enter, you can actually run pound debugger right now. Okay, so run it as quiet behemoth 3. Okay, so actually behemoth 3. Okay, it's not behemoth, so behemoth 3, right? So once you run it, so this is just like GDB. All the GDB commands would work. So basically disassemble main, this would work, right? So you can actually disassemble into the assembly code. Okay, so basically there's a print function initially, and then there's a get function, fgets, right? And there's a print function again, and finally puts function, right? So we have seen all these functions, and we just by changing this, the input is limited, but when we use format string vulnerability, we can point this to a different location. So basically we don't need the PLT version of this location, we actually need a GOT version. Okay, so basically global offset table of this puts. So global offset tables are nothing but they have only one global address. Okay, wherever you go you can use the same address. So basically when you're inside pound debugger, use the same address. When you're in some other location, or when you're using some other file, you still use the same location of puts. Okay, so this pound debugger has a shortcut command for that. So basically if you use GOT, which is a global offset table, and the function, which is this one, right? So if you hit that, okay, the program is not being run. So basically you have to run the program and then start this. So basically let's keep a breakpoint right here just after the puts command. Okay, just after the puts command we're just creeping a breakpoint. So you can use something like this. Okay, or you can use something like main plus this number which is there. Okay, so 86, main plus 86. So you have to give this asterisk. So basically you're saying that you want to have the location of this location, right? So basically if you keep that, you would still have the breakpoint at this location, right? So I'm just removing that, and once you're done, so just run it and keep some random data just like that, and now you hit a breakpoint. Okay, breakpoint at this location, and now we have passed this puts function, and now we are at a different location. So now if you run GOT puts, you can see that this is the global offset table of this puts function. Okay, so this is not a PLT version. Okay, so this is very important, right? So just save this into this location, and let's go back, and since we know we can use format string vulnerability in this puts function, so what you can do is let's run the same command, but this time let's try to use something different. Okay, so something like this, %x. So let's see what's gonna happen. Right, so here as you can see, this is what we gave and this is what happened. Okay, so basically we printed this and we also wanted to print this in hex format. Okay, so 41414141 is like hex format of AAAA. Okay, so you can actually check that in ASCII table.com. Okay, so we just zoom in and here hex 41 is A. Okay, cool. Right, so this thing seems to be working, and let's also analyze this stack, which is okay. Right, so if we inspect this stack pointer, so we should get some data. Okay, so how we're going to examine is we're going to examine x is examine, okay, 20 words of data from the stack pointer. Okay, so as you can see, this AAAA is right here. Okay, which means our data is being added right here, right? So let's see, what do we do next? Let's run this again, and we also know that we have used 199 characters only, so we also checked this. Okay, so we used %x, right? So let's run this again, and this time let's say %n. Okay, so let's see what happens right here. So looks like nothing happened, but let's use this puts function location, which is this one, right? So let's keep that in little endian format. Let's keep this \x b2 \x 04 \x. You don't see any data right here, right? Which is actually 0, which means it's nothing, right? Even though it has nothing in before this 8, we have to give in pairs actually, right? 0 8 or something like that. Okay, so 0 8. So this is the hex, I mean the little endian format of this, right? So now we're going to give this data. Let's see what's going to happen, and let's run it. Let's give this data and nothing, right? So we have to give this data in a different format, and even if you give the format like this with %n, we're still gonna see that this \/ is being escaped. Okay, so that's a problem, right? So if it is escaping, it is just printing it as a string. It's not printing it as hex code. Okay, so in order to do that, all you have to do is run this, and you also need to give the input directly right here. Okay, so echo, I'm just using echo. You can use Python or Perl or any other command. So I'm just using echo because it's pretty easy for this one. So the string which I want to give is this, let's say random characters and %n. Okay, so let's see what's gonna happen. Okay, so did something change? Nothing. It just prints out this this as dereference or something. Okay, so it's in ESI as well. So nothing, no, we're not just changing any memories or something. So here let's replace this with the code, the little endian format of the puts function. Okay, so this is where the puts function actually exists, right? So when we keep something like this, what basically we're basically telling that go to this location and the number of bytes is 4, right? And the number of bytes is represented by this percent %n. Okay, so basically the 4 bytes of data, I mean the 4 bytes, which is the number of the bytes, is stored in this location. Okay, so if you hit enter, which is puts, right? So puts got plt got a number 4. Okay, so the number of bytes is stored in puts function. Okay, so if you go back, you can see that invalid address, this one, which is 4 bytes of data, which is very interesting, right? So let's say I want to override this location with not just 4, with some other data. Let's say I just want to give my own address. I just want to override this address with ff, let's say fedcba, something like that. Okay, so this should not exceed like 4 bytes of data, like 8 bytes of data. So basically this is how the memory address is, because we want to represent in pairs, right? So since we want to represent this in pairs, we have to give something that has pairs in it, right? So let's use this. So how do we represent this? So \xba. So we don't actually need to do this, so we just want to rewrite this puts location with this. Okay, so how do we do that? This is gonna be interesting, just watch. So first of all, we know that this is our location, right? So basically we need to print the decimal format of these different parts. Okay, so basically we divide these into 4 different parts: 0xba, okay, and let's say 0xdc and 0xfe. So we're just dividing this into different parts, so that it's easy for us to change each byte into different location. Okay, so finally 0xff, so I'll just copy paste it right here. So now we have 4 bytes of data, 4 hex bytes of data, right? So each one is like 8 bytes or something. So we cannot give a single byte because the program doesn't understand, so we have to give it something like 8 bytes or something. So here also, let's say 0xba. Okay, this is what we want. So if you just type the decimal format of this will be 186, right? So we'll just keep them side by side, 186, right? But when we are sending data something like this, we are also giving the data like this, right? So we cannot give 4 bytes of data, we have to give like 8 bytes of data. So as I said, we need to have, let's say I just give it like this, and let's see what happens. And we also need to give the number of bytes, the number of padding, which is 186, and we have to give it in hex format, which is x. Okay, we already checked that hex format already before, right? So 186 padding of hex format, and store this into this location, right? So let's see if that actually works, because this is not going to work because we're only giving 4 bytes of data, right? So let's hit enter. So as you can see, nothing happened, no crash, nothing like this. Okay, so we're not overwriting any data in any location, so we need to give some random characters which have at least like 4 bytes of data, like 4 bytes of data here and 4 bytes of data here, and which will make 8 bytes of data. Okay, so 8 bytes of data will give at least some kind of a word or something, right? So that the memory can actually understand. So since you keep 8 characters here, so you need to change this as well. So let's hit enter and see what happens, and then we'll change later. Okay, so here you see C2. Okay, so this is not we want BA, right? So how do we change it? We just go back to this p/d, which is print in decimal format 0xBA, and subtract this with the number of padding which we already gave. Okay, so the number of characters which we already gave are 4 characters of this one and 4 bytes of this one, right? So totally 8 bytes. So we need to subtract 8 from that. Okay, so simple enough. So this is our new padding right now. So go back, change this with this and hit enter. And now if you scroll up, you can see that 0xBA has been replaced successfully, right? So now let's go to DC. So for this, you need to give the same way, just like this, but you also need to give it twice. Okay, so till here, not this %x and %n, till here. Okay, so now this location we already understood that this is 1.8 location. So the next byte we need to change is 1.9. Okay, so we're now changing this location, and in this location 2 hex characters has to be present. So in this 2 hex characters we're going to place DC. Okay, so how we're going to place it? So when we keep something like this %x and %n is for the first one, which is the first 8 bytes of data, and we also need to give %x and %n for the next 8 bytes of data. Okay, so now we also need to give the padding for this, so we need to calculate it first. So let's hit enter, and you can see that it completely changed. So we need to change the padding again. So this time 0xBA, we have to go from the beginning, and this time the number of bytes we are using are 8 bytes here and then 8 bytes here, right? So total 16 bytes of data. So you need to subtract that, and finally you got 170, and now you need to use the same command again. So this time when you say DC, you have to subtract this padding whichever we got from here. Okay, so basically it is the offset. So offset, you just remove that and you get 34, right? So the offset for BA is 170, the offset for DC is 34. Okay, so go back to this command and keep 34 right here and 170 right here. Okay, so if you hit enter, if you just scroll up, you can see that DCBA is there, right? So let's see. Okay, right. Let's move on to the next one, which is FE. Okay, so we have successfully replaced the memory address of DCBA, and let's try to remove this. So for this also, you just need to copy 8 bytes of data, right? And go here, paste it one more time, and since you need to access the next byte, which is like 1819, and the next hex byte is 1A. Okay, so 0 to 9 and A to F, right? So 0 to 9 and then next A. So here again you need to give %x and %n. So let's just run this and then see what happens. This memory address has changed, right? So what we need to do again, like p/d 0xBA and minus, this time how many bytes we need to reduce, like 4 bytes of this one, 4 bytes of this one, and 8 bytes of this one, right? 8 bytes of this one, and the 8 bytes for the third one, right? So totally 24 bytes of data has to be removed for the offset. So it's 162. So now let's go to DC and remove 162 from here, and it's 34. And now scroll up. Now let's give FE because that's the next one, and remove 34 bytes of data right here. Okay, now you got 34 again. Interesting. So now the padding should go something like this. So 162. So people make mistake here because they don't change the first one, and then 34, and then 34 again. Okay, so now if you hit enter, this should change it to FEDCBA. Now finally FF, right? So let's change that directly. Okay, so let's change this from here. First of all, let's add 8 more bytes of data. And change the memory address where you want to change, which is the next address, which is B. Okay, and finally %x and %n. Okay, so let's see, this is not the address we want. We want the location of the offset, which is 0xBA minus this time 4 times of 8 bytes of data, which is 32. Okay, so 154, and now DC, let's keep 154, and now we got 34. Now let's go to FE, and here is 34 again, and now you got 34. So let's go back, FF minus 34. So this is very interesting. Okay, so now you got 1. So you cannot keep 1 actually. So let's try to keep 1 and see what happens. So if you keep 1x, it's nothing but just x. Okay, so it's not gonna just change everything. So if you hit enter, you can see that the address doesn't change. And as I said, you also need to change this memory address, which is 154. And as you can see, nothing will change in this address. Okay, so everything else we actually got it, but this one we didn't get because we shouldn't keep 1. Okay, even though we calculated it to 1, we shouldn't keep 1. So here something interesting is going to happen. Okay, so we're going to use the same command, and this time, since 1 doesn't mean anything in hex, so basically, like, if you're just keeping 1 offset, we're not keeping any offset actually. So if you just keep 1 here, so it will actually give like 256 more offset. So what this is going to do is it's going to give this value, which is 257. Okay, so 256 plus 1 offset, which we got from all of these things, right? So if we keep 257, let's see what's going to happen. Okay, so as you can see, the whole address has changed, and EIP has been replaced with this address. So EIP is basically the extended instruction pointer. So whenever the CPU want to interact with the program, all the instructions are given by this EIP. Okay, stack just stores the data, and a few others will just try to store some data as well, but this one is the only thing that is asking for next instruction. Okay, so basically we have successfully replaced this with our address. So what we need to do now is we need to replace in similar way a different address that actually points to something like a shell code. Okay, so this shell is not the shell we actually want. The shell variable is different. So let me just exit out of here. If I type echo $shell, it's different. Okay, it's bin bash. It's not the one we want. Okay, so we can actually use this, but we have to use shell code. Okay, we want to execute a shell code. We don't want to run shell bash shell, right, like this. Okay, so for that, basically I want like 606. Does it exist? Yes. So I like this shell code, so I always use this shell code. So you can actually copy paste right here. So I already have it stored, so I'll just use that. Okay, so basically like export shell code equals to this particular command. Okay, so I already gave some no operation characters like this. Okay, so whenever the shell code, like the point where I want to redirect the puts function, so if it falls anywhere between that, then it's gonna just fall down and execute the shell code right here. Okay, so I can hit enter and save this shell code right in the environment variables. So now, so I need to know where the shell code is. Okay, so you can execute this in multiple ways. So what I want to do is, so this is where everything got messed up actually. So whenever any program executes any variable, it just temporarily stores in a different location. Okay, so for that, like everyone just messes up this particular thing. So what I want to do now, so what I had done is I had to go to this hacking the art of exploitation. This is the book. So if you just go here, art of exploitation, so this is very old book, right? So I'll just go to images. Okay, so this is the book. Okay, so I had to go to that book and I have to check how to get the environment variable for shellcode. Okay, so this is the code. Okay, so get env.c or something. So the name doesn't matter, you can give any name you want. So basically it gets the environment address. So this is the code. So we're going to write this code, or you can just copy paste it. So I think I can just copy paste it to save some time. So I've already stored it right here. Let's go back right here, paste it, and I already have this temp directory, right? I don't think I have temp directory right here, right? So let's use that. Let's see, echo $temp doesn't have anything. So temp equals to dollar, basically it's a subshell. So dollar bracket is nothing but subshell. So basically it will execute this command and the output, whatever comes, is stored here. Okay, so -t and hit enter. cd $temp and chmod as well, $temp. Okay, now everything's perfect. So let's use nano, let's say address.c. okay, so I'm gonna paste it right here and I'm gonna explain these things. So these are the standard input output headers, and this is the standard library header, and this is a string header. Okay, so we're going to need this string to actually get the string length and everything. Okay, so let's go through this main function. This main function, okay, so it's better if I explain in the book. Let's go to the book. Okay, So I think you can see better right here, right? Yes. So basically this is the main function, and the main function takes the arguments. Okay, doesn't matter what the arguments, and it stores in as a pointers or something. Okay, so here we have a character pointer, which is actually a pointer, right? And if the arguments less than 3, which is actually like if we don't give like two arguments, so basically like argc is like it's just counting the arguments. So if we do not give like at least two arguments, so if it is less than 3, the first argument is basically argv of 0, second is the argument of this argv of 1, and the third one is argv of 2. So we need to give at least 3. So the first one is basically the name of the file itself. Okay, so in this case the name of the file is arg address c or something like this, right? So this is the first argument, and the second argument is the environment variable. Okay, and third argument is the program name itself. Okay, so basically if this program is running, then what is the environment address or something? So the variable actually changes its location whenever a new file accesses it. So this function will take it, and it will just take the get the environment variable of this one, which is the shellcode, and then stores it into ptr. Okay, so get the environment var location. So this is the function that this particular get environment does. Okay, and then it adds to this the difference between the argv of 0, the string length of this one, minus the string length of the the third argument. Okay, so this actually, once you do this, you have to just multiply with 2, and the difference would actually adjust for program name. Okay, so based on the program name, it just adjusts the memory address of this shell code is adjusted. Okay, so we need that to get an accurate shellcode location. Okay, so %s will be at, so it just save this, control x y enter, and if you just type ls, you can see this, right? And you need to execute this, and you need to get an executable out of this C code. So to get executable, they have given some instructions, something like this. Okay, but this is not how you need to do. Okay, because we need a 32-bit version of the shell code, so we cannot directly use that. Okay, so basically you need to use gcc, and you need to say go to this mode 32, which is like use I want a 32-bit version of an executable, and you can give the file name, and finally the output has to be something like an executable like this. Okay, so finally, like, we got the executable. Let's give the permissions addr, and now you can execute this file. Okay, so let's give addr, and the variable is shellcode. You have to give the caps lock as well, so capitals of this or small, whichever you're storing. So shellcode, and finally the program, which is behemoth 3. Okay, this is the file, and based on this file name, the shell code location is actually adjusted. Okay, so hit enter, and this is the new address that you get. Okay, so you store this address just like this address. You need to go and change all of these things. Okay, so this is going to be interesting. Let's check this out. fe d4 fd, and is that right? Look, no, ff and ff. Okay, so now let's use this. Let's go pound debugger p/d and this one. So this is what we want, right? So this is what we want to change our memory address to. Okay, we just want to change the memory address of puts function to this location. Okay, so fe, and we know that we have to give like 32 bytes of data. We have already seen that to change the address. So just keep 32, and here you got the first offset. Okay, and next d4, and let's give 222, I mean the minus 222, and this time we got a negative 42. Okay, so this is going to be interesting. So here you need to add like 256 bytes of data, I mean 256 offset, by just keeping a 1 in front of it. Okay, so basically you want to add like 256 bytes of data so that you can actually convert this into positive. Okay, so if you hit enter, now you got 214. Okay, so just like we did previously, we added 1 here. Okay, so we did for the previous one as well, right? And finally, what is the next one, which is ff. So here also, since you're using 1 already, so you have to use this one again. Okay, so 214, so this is the next offset, which is 43, and next one is also ff, so you can just continue this and subtract 43. Okay, since you get 0, you have to add one more hex value, which is 2. Okay, now you got 256. So these are the offsets you need to keep. Okay, 43 and 256. So let's keep that and execute. Let's see if there's any people in the chat. Okay, everyone's sleeping. All right, so let's get this done. So we already used the echo command right there, right? So, and we know that this is the global offset table memory address for puts function. Okay, so this is for puts function. So we'll use 8 bytes for each data, right? So we have to use 8 bytes for each data, and we'll just say echo -e to execute it, and we'll execute this multiple times. Like we need to give at least 32 bytes of data, right? So we have to paste 4 times. So 1, 2, 3, and finally 4. Okay, so total 32 bytes of data, 4 into 8. Okay, and then you also need to give %x, %n, %x, %n, %x, %n, %x, %n. Okay, so for each 8 bytes of data, like for this location, this one, and the next location, next one, next location, next one, and so on, right? And you need to change this location to the next byte, which is 19. The next byte is 1a, next byte is 1b. Okay, simple enough. And the offsets that we get are in this, right? So 222, which is right here. The next one is 214 here. Next one is 43 here. Next one is 256 right here. Okay, so now this is done. Okay, so now let's get out of pound debugger, and to execute this, let's keep a bracket something like this and send this output to /behemoth Okay, it's not working. Yeah, looks like this double quotes is causing the problem, right? So you have to end this with the double quotes, right? You can also end this with the semicolon, doesn't matter. So now the behemoth actually works. Now the tab is actually working, right? So behemoth 3. Let's see what's gonna happen. Okay, so as you can see, there are no errors, but if you change anything here, it's gonna cause some error. Okay, so let's keep something like 255 or something. Okay, so it created a segmentation fault, right? Just by changing one offset, it's just causing a problem. So you have to be like pretty accurate. And since this one is not causing any problem, which means we actually pointed to a right location, but we're not keeping the input stream open. Okay, so this is basically because of this one. Okay, so there is a function called IOCTL. Okay, this is actually causing a problem. This is not letting the input stream open. Okay, so this is like input output control. Okay, so it's actually controlling the input and output. It's not letting us use the input stream. So we have to use something like a cat. Okay, so basically cat command will actually keep the input stream open. Okay, so if I just type cat, you can see that the input stream is open. I can type anything and that would bring us to the output. Okay, so we're just basically doing the same thing. So we already typed the command here, so just copy paste it right here. Okay, now remove this and close this with brackets. Now we're ready. Let's hit enter and let's see what's gonna happen. Okay, so now I kept the input stream open. Like if I type who am I, behemoth 4 ID, behemoth 3, but effective user ID is behemoth 4. Okay, now I can get etc behemoth. Okay, tab doesn't work. Underscore pass behemoth 4, right? Okay, got this finally. And this is the behemoth 4 password. I forgot to do one thing, so I forgot to increase the rank. So let's use Control C. So without exiting this, because I already logged into behemoth 3, I have to type vshell. Okay, this would automatically update the score and rank right here. Okay, so just hit enter. And it's taking some time. Just hit reload. Two, 3, 8, 8. Come on, increase the rank. It's taking its time. Okay, taking its time. So let's type cd and vshell. Let's type it here. Okay, success. We've already solved this challenge. Nothing has changed. Reload. Okay, the score has changed and I already beat this person. Interesting. So if I reload, I've already beat the bad boy. Bad boy 17. All right. So 171 points. Oh my god. So that's why I was able to beat that person. Okay. Let's see. Who's next? Do you see any person from India? Okay, Storm Worm. So let's see. $35. Okay. Currently I'm at 36. I'm gonna beat this guy next time. I'm not sure anyway. I'm not sure because he's like too high, I guess. I'm not sure. Okay, 200. Okay, so yeah, let me see. Let me log in to Bandit. I mean Behemoth 4, and let's try to use this password and reach out. Let's see how much my score will increase. So it is 171, right? So possibly 172 score will be added right here. So let's reload. Okay, not yet updated. 172. 172. It's just pushing the rank. Come on, come on. Okay. It's gonna take its sweet time because it's gonna push all these ranks, right? Stormworm, you're next. You are next. Alright. Now can I reload? Okay, the rank has changed and still 36. Okay, 440. I can actually beat this guy next time. Okay, it's gonna be interesting. I'll see you guys in the next Saturday, possibly next Saturday. Where am I? Right here. I should be around this location. Right here. I'm gonna beat this guy next. I'm gonna increase my rank. All right. I had fun. I hope you had fun as well. I'll see you in the next video. Bye bye.